Today we are talking about cylinders. Cylinders are very similar to prisms. They will also have two bases. The difference is that cylinders only have circle bases. So in a prism, we could change it between a square, rectangle, trapezoid, hexagon, triangles. We had lots of different options. So they call it something different. They call it a cylinder because the base is a circle. And circles have, pi in the formula, so we call it something different. It also doesn't have edges and vertices and stuff like that. So anyways, we've got from the center to a point on a circle. That is our radius. That is your R. And the distance between the two bases, that is your height of the cylinder. And so you can kind of see that internal height right here on the three-dimensional shape. It does show that it's perpendicular, and that just says that we're not dealing with slanted cylinders or anything like that. So, and because it is a circle and it has pi in it, we will leave our answers in terms of pi. So I said already that they are very similar to prisms, and so we're going to look at our prism information. Our lateral area before. So our lateral area formula for a prism was perimeter of the base times the height. Well, with a circle, we don't call it perimeter, we call it the circumference. And our circumference formula is 2 pi r. Now, before we left it as p, perimeter of the base, because the base could change. It could be adding 3 sides for a triangle or 6 sides for hexagon. But since now the lateral area is strictly only a circle, we're going to go ahead and substitute this information in. So we are going to do our 2 pi r, the perimeter exchanges for circumference, and times that by the height of the cylinder. Then before, our surface area was LA plus 2B. We still have 2 bases, so we're going to still continue along that same thought process. Now, the lateral area, that formula, I'm going to just copy right on over, was 2 pi RH. And we're going to add 2 times the area of the base, because again, there's 2 bases. Well, the area of the base, we have a circle, and y'all know me and my colors. I'm trying to pick a good color. So your big B, the area of the base, area of a circle is pi r squared. So we're going to take 2 times our circle area, pi r squared. And then volume before was area of the base times the height. And again, the area of the base right up here is your pi r squared, and times that by our height h. So all of these things, just like last time, Our lateral area is going to have units squared. Surface area will have units squared, and volume will have units cubed. And if you look, we really only have two variables. We have the radius and the height. And if we have both of those things, then the rest of this is just quick, quick, quick. So we've got lateral area is 2 pi RH. If we look over here, our radius is 7, so I'm going to substitute that in. And our height is 6. So then we multiply those things together. 2 times 7 is 14. 14 times 6 is 84. Now earlier we said we are leaving in terms of pi, so we're not going to plug pi in the calculator, but it is part of our answer still. So we have 84 pi with inches squared. Next we have surface area. Surface area is LA plus 2B. Lateral area plus 2 times the area of the base. Lateral area I had earlier, we can plug it in, and plus 2 pi radius is 7, and we square it. So simplifying this down a little bit more, I've got my 84 pi. Now over here, I've got 7 squared is 49. 49 times 2 is 98, leave in terms of pi. Now in our last lesson, we had some of the answers where one of them had a square root and the other did not, and so we realized we had to leave them separated because they weren't like terms. Well, same idea goes with a pi. However, they do both have pi. They are like terms. So I can add them together for a total of 182 pi and inches squared. And as a reminder, that surface area should always be bigger than the lateral area because the lateral area is the around part. And then the surface area is the around part plus the bases. And then last we have volume. Volume is area of the base times the height. Base being a circle, pi r squared, and times that by the height. My radius is 7. My height is 6. And multiply all that out, you should end up with 294 pi. Now remember, volume is basically how much Pepsi Zero, Mr. N's favorite drink, which Teacher Appreciation Week is coming up. Cough, cough, hint, hint. That is how much Pepsi Zero can we fill inside that can. So it is inches cubed. And this volume isn't going to have a direct relationship with either one of those because it's a totally different thing. It's 3-dimensional instead of 2-dimensional. All right, so next we have this. Now, looking right off the bat, we've got this line here. Notice that line is not going through the center, so it is not a radius, and it cannot be a diameter either. So I'm going to actually key in on this sliver of a triangle. And I'm actually going to expand it up here. So this triangle says this hypotenuse is 3 square root of 2. So then we have to think about, what do we know about these other two sides? Well, notice it's coming from the center to a point on a circle. Well, from the center to a point on a circle, that is a radius. So if I can figure out that length here, then I know my radius for my formula. Well, if you look here, that's also from the center to a point on a circle. So even though it looks shorter, it's just how we have to kind of manipulate the picture to draw a 3D shape at that perspective. So this radius up here is the same as the radius over there. And so if they are the same, this is an isosceles right triangle, which is your, there was a teacher who had a rule for right isosceles. X root 2, x root 2, x root 2 for 45 90s. So if we look at our given information, these both have a square root of 2, which can kind of cancel itself out. So we end up finding out that x has a value of 3. And if x is the length of that, that means our radius is 3. Cool. And then we've got 5. 5 is the height. So now we have all of our information. And actually, I did want to add something up here. I forgot to write it down. I was talking about from the center out, that's a radius, and how this is also a radius. So we're going to write a remember that all radii are congruent. And so whether that radius is going this direction or that way, that's why they're the same. Okay, so lateral area is circumference times the height, 2 pi rh. Radius is 3. My height is 5. 3 times 5 is 15. 15 times 2 is 30. Leave in terms of pi, and these are feet squared. Then we have surface area is LA plus 2B. Lateral area plus 2 times the area of the circle. Lateral area we had earlier, we plug it in, and plus 2 times pi radius, and square it. Simplifying this down some more, 3 squared is 9, 9 times 2 is 18. Do they both have pi? Yes, they do, so they are like terms. So we end up with 48 pi feet squared. And last we have volume. Volume formula is area of the base, pi r squared, times that by our height. So we've got pi radius squared times our height, and 3 squared is 9, 9 times 5 is 45 with our pi and feet cubed. So not too bad. In our last problem, we're doing is practicing working backwards. Notice there's not a picture, so that is one of the first things that we're going to want to do. Geometry is very visual, so we always draw our pictures. We need a radius and that internal height here. Okay, so I'm looking at my given information. They gave me the lateral area is. So that tells me the first thing I need to write down is the lateral area formula, 2 pi r/h. And if that is my given information, that the lateral area is 48 pi, I am going to substitute that in for my LA. I am plug it in, 2 pi, and then r and h. Now going back to the rest of the information, they did tell me the radius is 4. So I added that to my picture, and I also added it to my given information. And they're asking us to find the height. So h is what I am looking to solve for. So what all is attached here? I've got a 4 attached, a pi, and a 2. So before I do some moving around, I want to simplify it down a little bit. My 2 times 4 is 8. And then now I've got h almost by itself. I still have the 8, which we're pretty familiar with, divide by 8, so it gets rid of that. But there's also a pi, and you can still divide both sides by pi. And anything divided by itself simplifies away to 1. And that includes over on this side, pi divided by pi is 1. And so we end up dividing out, and we have 48 divided by 8 is 6. So we end up with 6 millimeters. Be sure to add your units on those problems as well, and then you can start your assignment.